Alright, now guys, this is something completely new. You've never done something like this before. It seems quite complicated, but it's actually not that bad. What happens in these types of questions is, if we're looking at the first one, for example, they are telling you that there is a party pack of 3 items, and you need to make that party pack up by selecting one item from each of the following choices. So for choice 1, you need to choose either Smarties or Astros or Jelly Tots or Wine Gums. How many different choices are there that you can select there? Different things in choice 1. How many different items, if we count them? 1, 2, 3, 4. Right? You can choose one of 4 items for the first one. So I'm going to write next to this one, there are 4 options for choice 1. Okay, so that's basically sweets, right? There are 4 types of sweets that you can choose from. Then you need to choose a drink there. How many options are there for choice 2? Coke, Fanta, Sprite, ginger beer, cream soda. That is 5 options. Okay, so 5 options here. Next up, we have a pastry. All right. You can either choose a donut or a Chelsea bun or a cheese roll. How many options? 3. All right, let's not get distracted, please. Lunch is soon. Okay, they're asking us how many different party packs can be made. Now, guys, let's just think about this logically. If you choose Smarties for the sweet, right? You can either choose Coke and a donut. Okay, so that's one option already. Or you can choose Smarties and Coke and a Chelsea bun. That's another option. Or you can choose Smarties and Sprite and Smarties and Coke and a cheese roll. That's 3 options. All right, or 3 different party packs. So from these 3 choices here, we already have 3. Now, if we choose Astros and Coke and a donut, that's a 4th option. Astros, Coke and a Chelsea bun, that's a 5th option. All right, so we can physically count every single option like that, or what we can do is we can multiply the number of options for the first choice by the number of options for the second choice by the number of options for the third choice. That is the counting principle. You are going to multiply 4 and then 5 and 3, and that is going to give you the combination of total party packs that you can make. Kewan?
I'm confused.
Hi, we've just started. All right, so we are going to, let's write down here, number of party packs is going to be 4 times 5 times 3. 4 times 5 is 20, times 3 is 60. So there are 60 different party packs that you can make. That is what the counting principle says. If you have space at the top of your page or somewhere, we can make a little arrow. And we can say, if there are m ways of doing something, and n ways of doing something else, there are m times n ways of doing both. to the question. I will just not. Okay, we're going to practice lots more scenarios now, so hopefully it will make sense by the end of it. Okay, so that is just a very kind of informal way of writing the counting principle. The formal way is very complicated, which is why I just made it a little bit simpler. But basically, if they've given you a certain number of options for one thing and a certain number of options for the other thing, to get the total number of options altogether, you're going to multiply those together. Okay, let's look at the next one. The next one is saying we need to consider the word Florida. Now, how many letters are there in the word Florida, guys? 7. 1, 2, 3, 4, 5, 6, 7. Okay, so there are 7 letters. Now they are saying you are required to form different 7-letter word arrangements using the letters of the word Florida. So basically, you know those like little puzzles or things that you get in magazines sometimes where they ask you how many words can you make up using the letters of this thing. All right. So now the reason why they've said word arrangements is because if you have Florida, right, and you just swap the L and the O, is Florida a word? No, but it's a word arrangement. It's a letter arrangement. Okay, so we're not going to actually count the number of words specifically. We are just going to think, if we have these 4 letters, Florida, how many different letter arrangements can we get if we mix all those letters together? Okay, different words, we can use that. Okay, so now they're saying how many possible word arrangements can be made if, for A, the letters may be repeated. So what does that mean? That means we can have 7 F's, or 7 L's, or 7 O's, 7 R's, or we can have 2 F's and then an ORIDA, right? So what I want us to do for these types of questions, guys, is let's draw 7 lines. So just take a ruler. You don't really even have to use a ruler. Just draw 7 little lines. And I always say that these lines represent almost like slots. Well, let me just check. 1, 2, 3, 4, 5, 6, 7. Because if I have 7 letters and they're saying we have to make 7 letter arrangements, we basically have 7 slots. Okay. That these words are going to be made up of. So we can have Florida, or we can have 7 F's or 7 O's, or we can have 3 F's and 4 O's. All right, all the words that we're making, they are telling us here they have to be 7 letters long. Okay, so that's why I'm making 7 lines. Okay, so 7 letters long, so I'm making 7 lines. If they had asked us how many 3-letter word arrangements could we make, I would just make 3 lines. Okay. Now what we're going to write on these lines is we are going to ask ourselves, how many options are there for the first slot, the first letter of this word? How many different letters do I have to choose from? 7, right? Because there are 7 letters in Florida. Those are the 7 letters that I can choose from. Okay. So there are 7 options for that first letter. Now, how many options are there for the next letter? 7 again. Why? Because they said the letters may be repeated. Okay, so again, I can use any of the 7 letters for that one. For the next slot, again 7, right? For all of these, actually, guys, because I can repeat the letters, I have 7 letters to choose from for every single one of these slots. Okay, and what does the counting principle say? What must I do with all these 7s? I have to multiply them together. So we're going to say, you can write 7 times 7 times 7 times, or you can say 7 to the power of 7, right? Because what's 7 times 7? 7 squared. 7 times 7 times 7 is 7 cubed. Alright, so 7 of them will be 7 to the power of 7. What is that? It's a big number. Okay, no, let me rather just see it. Thank you, though. 823,543. So there are 823,543 words that we can make when we mix up all those letters. Alright? Including if they are repeated as well. Now the next one. How many can I make if the letters may not be repeated? Again, guys, how many letters must there be in these words? 7. So again, let's draw 7 lines. And guys, if you can eventually do these questions without drawing the lines, that's fine. Just even for me when I do these questions, it just makes it a bit clearer to actually see what we're working with. Okay, now the letters may not be repeated. So that means that if you put the F in the first, or the F as the first letter, you can't have another F anywhere else. Right? Does that make sense? Or if you put the A first, you can't have another A anywhere else. So how many options do we have for the first letter there? 7. Okay, I can use any of the 7 letters for the first slot. But now, guys, whichever or whatever letter I've used in the first slot, I'm not allowed to use again. So how many options do I have for the next one? 6. Now I've chosen 2 letters. Let's say we've used F and L. I can't use F and L again. So how many options do I have for the next one? 5. Now I've used 3 of them, right? I can't use those 3 again. I only have 4 options for the next one. Now I've used 4 letters. Now I only have 3 left to choose from. And then only 2. And then I will just have 1 letter for that last slot. If I've used F and O and R and I and T and A, I only am left with the L to choose for that last slot. Okay. What does the counting principle say? What must we do with all these numbers? We have to multiply them together. Now, guys, this is where we are going to learn a new notation. I am going to just quickly write down that I'm multiplying them all together. But a shorter way of writing this, where you have a number and then you are multiplying that number by all the numbers that come before it up until you reach 1, is an exclamation mark. I don't know if you've seen that on your calculators. On the silver one, it is over there. Do you see X with an exclamation mark? Guys, that exclamation mark is factorial. So that's what it's called. So this is called 7 factorial. Don't ask me why that is the name. I don't know. So instead of typing that out, you can literally on your calculator type 7 and then shift and that button there, and it will give you that exclamation mark, and then you press equals and you get your answer. 5,040. Okay, any questions on that one, guys? All right, do the next one on your own quickly, please. It's the same type of situation. We are now working with the word random, which is 6 letters, and we are required to form different 6-letter word arrangements. So because of this, we are going to do 6 lines. Again, if you can do it without the lines, fine. If you're a bit unsure, draw the lines. In each slot, you're going to fill in how many options there are for that letter, for that slot. For the what? The exclamation mark. It's just a notation for that. So if it's 8 factorial, it would be 8 times 7 times 6 times 5 times 4, 3, 2, 1. If it's 3 factorial, it's 3 times 2 times 1. So it's always this number, and then you multiply it by the whole numbers before. But the only place that we ever use it is in this section. It doesn't come up anywhere else. Absolutely not. If you want my illness, then you can. I have a bit of a cough. Alright guys, let's look at that. The letters may be repeated. So how many options do I have for this one? 6. And then for the next one? Again, for all of them 6, right? So this is 6 to the power of 6, which is 4, 6, 6, 5, 6. Oh. Alright, and then where the letters may not be repeated. So now guys, if you use R for the first one, you only have 5 for the next. Okay, and then once you've used those first 2, you only have 4 left. And then 3, and then 2, and then 1. So now instead of writing all of that out, 6 times 5 times 4 times 3 times 2 times 1, which you can if you want to, but you can also just write 6 factorial, which is equal to 720, yes, 720. Okay, I'll find that one. Now let's look at one that is a little bit different. How many different ways are there of predicting the results of 6 soccer matches where each match can end in either a win or a loss? Okay, so now how many matches are there, guys? 6. 1, 2, 3, 4, 5, 6. I'm going to have to make a prediction for 6 of those, for the 6 matches, right? So each of those matches. Now, we can't draw here, apparently. It's saying can end in either a win or a loss. So how many possible outcomes, how many predictions could I make, or how many predictions do I have to choose from, or options can I choose from for the first match? 2. I'm either going to choose win. I'm either going to choose, when I'm thinking, when I'm making my prediction, I'm going to say win or loss. 2. Yes, Kewan, do you agree? If they had said a win or loss or a draw, you could say 3. Alright, that would be 3. For the next match, that one can also either be won or lost. So there we go, 2. And then 2, and then 2, and then 2, and 2. For all 6 of those matches, they are either going to win or lose. Or that's the prediction that we can make. Alright, so what is this now? How am I going to calculate this? 2 to the power of 6. 64. Think about that next time you put in your parlay. Alright, so we started that one with number 4. Never mind, it's a bit of an inside joke. Alright, number 5. Okay, number 5 is where things get complicated. Quickly read through number 5. I just want to space my page here a bit.
This is just a question, like, just like a random. For sports betting, can mess up.
Yes, it does.
Like a lot.
It depends on your understanding of. But yes, it's maths. It is maths. Yeah. It's probability. Why is everyone saying ma'am? You guys are making me feel anxious. Okay, yes, I'm listening.
I'm afraid of sounding stupid, but just
Okay.
there's six soccer matches, no?
Yeah.
And then can I in the video maybe 12 outcomes? That's what I said, and you laughed at me.
The thing is, you are multiplying the possible outcomes of each of them with each other. So you're not saying there's 6 matches and there are 2, so you're timing 6 and 2. You're thinking of it as there are 6 soccer matches, so there have to be 6 lines. So it's like what we had with the word random. It was also 6 letters that our answer had to be made up of, so 6 lines. Okay, let's do the next one and then maybe it will make a bit more sense. Okay, but that's a common question, don't worry. Alright, we are now going to be talking about how many passwords we can make. And this is a very common final exam type question. So for 5, sorry, I just had to respace my stuff quickly. They are telling us that a password is to be made up using the format XXX and YY. So how many digits, how many slots in that password, guys? 5. So I'm going to draw 5 lines for each of these. Okay, so this XXXYY is telling me that I'm going to have to use 5 lines. Where X represents any digit from 0 to 9. Alright, so this password is going to have to start with 3 numbers. Okay, from 0 to 9. And Y represents any letter of the alphabet. So we're going to have 3 numbers and then 2 letters. Okay, how many different passwords can be formed in each of the following cases? For A, the digits and letters may be repeated. So we are doing our 5 lines, 1, 2, 3 for XXX. And then we're doing 2 lines for Y and Y. Alright, how many digits or how many numbers are there from 0 to 9? That's 10. Okay? Because remember we're counting 0 as well. Okay, so it's 0, 1, 2, 3, 4, 5 to 9, so that's 10. Okay, so for the first X, we have 10 options. Now guys, we can use the same number more than once. They're saying that we can repeat these. So for the next one, we also are going to have 10 options. And then for the next number as well, 10 again. Because we can do a 111 or a 333 or a 232 or something. Okay, we can use the same letter or the same number multiple times. And now for YY, the last 2 digits of this password, those have to be letters of the alphabet, which is 26.
I can't say all this.
Alright, and then the next one, they can be repeated, so again 26 options. Alright, so how many options do we have here? Or how many possible passwords can we make? 10 cubed times 26 squared. Yeah, it's going to be a very big number. 676,000. So imagine you are trying to guess someone's password. And there are 676,000 possible combinations. It's going to take you a while. Alright, B. Yes.
So it says X represents any digit from 0 to 9. So why do we choose 10?
No, we're not choosing 10. We're saying there are 10 numbers to choose from.
Oh.
Okay, so the numbers that we're filling in here are not the actual numbers that we're putting in. It's the number of options that we have. Okay. Alright, for the next one, again, 5 lines, please. 1, 2, 3 for the numbers. And then 1, 2 for the letters. But now they're saying that none of the digits or letters may be repeated. So now if we're using a 0 for the first number, we can't use that 0 again. Alright, so now we have 10 options for the first one. How many options for the next one? 9. Good, because we can't use the same number that we started with. And now we have 2 numbers already, so now we only have 8 to choose from. And now if we're doing letters, there are 26 letters that we can choose for the first one. But say now we've put an A in the first one, we can't use A again. We only have 25 options for the next one. Now guys, here you can't use factorial. Okay, because factorial, if you wanted to write 10 factorial, that would be 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, 1. Okay, so we can't use factorial here. So we are going to have to just write out 10 times 9 times 8 times 26 times 25. Right, so you can only use factorial if it's all the numbers from the first one to 1 that you're timesing together. Let's see what we get for that. 468,000. All right, let me quickly move the next question up. Read through the next one on your own so long and think what the implications of that would be. Okay, now they are giving us some more conditions here, guys. Now they're saying, listen up. Thank you. The digits, the digits and letters may be repeated, but now we can't use 0 anymore. So now, do we still have 10 options for the numbers? No, now we're only going to have 9. And then they're also saying that the vowels must be excluded. So there are 5 vowels. Hey, yes. Sometimes Y is a bit of a gray area, but let's ignore that one. Okay, A, E, I, O, U. Some people say that Y is a vowel.
Why is it
8. Oh, H. Yeah, it's because sometimes if you have a word that starts with H, because of the pronunciation, you would put an in front of it instead of an A. But officially A, E, I, O, U. And then, yeah, so now if we're starting with 26, now we're taking out those 5. So now, can we actually do this one without lines, guys?
Yes.
Can we think? It's 5, right? 3 numbers, 2 letters. How many options do I have for the first number now? 9 times 9, but they're saying they can be repeated. Okay, yes. 9, and then for the third number also, 9 times 21 times 21. Or you can write 9 cubed times 21 squared. Right, up to you. 3, 2, 1, 4, 8, 9. 3, 2, 1, 4, 8, 9. Okay, do the next one on your own for me, please. The digits and letters may not be repeated. And the number 0 and the vowels must be excluded. So again, we are working with less options now because we now can't use 0 and we can't use the vowels. But now they're also telling us that these digits may not be repeated. What? You can if you want to. Yes, try it. What are we talking about now? Oh, prime. No, 1 is not a prime.
What?
That's 5. That's 9 is what do you mean 0?
No.
I know this.
Alright, there we have the answer to D. D. What now?
For E, man.
Let me just first talk about T. We'll get to E now. Alright guys, are we okay with that answer there? So because we're going from only 1 to 9 now, we have 9 numbers to choose from. But now because they may not be repeated, we can't use the same number twice. Alright, same thing with the letters, 21 for the first one and then 20 for the next one. Okay, let's talk about E. The digits may be repeated, but must be prime numbers, and the letters may be repeated, excluding the first 5 letters and the last 5 letters. So we're excluding 10, so we have 16, right, to choose from. Okay, now let's quickly count the prime numbers. Maybe I must list them here for you so that maybe write them down. 2, 3, 5, and 7. Those are the prime numbers between 0 and 9. There are more prime numbers, but those are bigger than 9. So those are not relevant here. So we actually only have 4 now to choose from. Okay, 2, 3, 5, and 7. Okay, so for E, let's think. We have 5 slots. All right, the first 3 are numbers. How many numbers do we have to choose from for the first one? 4. So 4 times, can I repeat them? Yes. So again 4 times again 4 times. Now the next 2 digits must be letters, and they've told us we must exclude the first 5 and the last 5. So 10. So we have 16 options for the first one and 16 for the next one. Or if you want to, you can write 4 cubed times 16 squared. Oh, no, that's too complicated. Okay, how are we feeling, guys? Can we try some on our own?
Yes, ma'am.
Right. Oh, it's written on the page there. What you must do for homework, please.